Okay, so circles. By the end of the hour, we're going to make sure you know how to get a circle, and you're also going to be able to write the equations of a circle. Just to clarify, a circle is not a function because it doesn't pass the what? Vertical line test. Good. So if it doesn't pass the vertical line test, then it's not a function, but you can break it into two functions. All right, we'll talk more about that in a moment. So right now, would you get to this? What makes these circles different? There's a lot of things. They're in different places, right? What else? Size. Size of the what? They're using words for circles. The radius. The radius is size, for example. Well, that kind of goes with the diameter, right? Diameter is all the way across. Radius is from the middle out. All right. So basically, we're going to give you the definition of a circle here. And we're going to get it from the Pythagorean Theorem. Would you agree that if I have a little triangle right here, that logically we could name this distance right here x? Because it's an x kind of thing. It's on the x-axis, right? And this height here that's green, does it make sense to you that that could be y? Because we don't know how long it is, and it's an up and down distance, right? So then this is like the radius of the circle, right? And it's also the hypotenuse of our triangle. Are you with me so far? Now, what do you know about triangles? What's the fact you know about triangles? Raise your hand and tell me something. Yes? Yes, I was hoping somebody would say that one. All their angles add up to 180. There's something else we know about circles. Yes, sir? The hypotenuse is longer than the other two. Exactly. This has to be the longest side. The hypotenuse does. Both true facts. You got another one? Yes. Yeah. So like this and this together have to be bigger than that side. I agree with that. That's true. There's one. Yes? Oh, wow. They were talking exterior angles now. Okay, good. This is all good, but it says it on the board, for Pete's sake. Somebody tell me something you know about triangles that hasn't been said yet. Yes? The Pythagorean Theorem. Can anybody tell me what the Pythagorean Theorem is? There you go. A squared plus b squared equals c squared. That's something you know about triangles, right? That a squared plus b squared has to equal c squared. Well, then somebody smart tell me the equation of a circle. Yes? You can do this. Got a placeholder in because you got your hand up first. Can you do it? The equation for this circle right here. She's ready to take over if you can't do it. Come on, step up. You can do this. A squared plus b squared equals c squared. So?
Oh, x squared plus y squared is equal to
1 squared, which is 1. All right, good. That's the equation of a circle. It just happens to be equation of that circle. Now all we'd have to do is move it around and like make it bigger and stuff. Like, can you get that if I change this from a 1 to a 2 that the radius just got bigger? Does that make sense to you? Okay. And how about this? What if I wanted to move my circle and I didn't want it to be just at the origin? What if I keep the radius the same size, but I want it to go from being at the center right there at 0, 0. What if I wanted to like move it right to the right? Come on, somebody take a guess at this. You can do this. Something with the x has to do with the x, yes? So give me the equation for that little circle. It just got shifted to the right. It's like this, except something's different, except with the x. You want to give it a shot? Let's say it shifted 3 spots over. Oh, yeah. Yes. You just moved it to the right 3. Does that make sense? It does make sense because we go to the right when we do -3 on the inside. Remember? So then how about if I take this little circle and I move it up? Let's say up 1. Just 1. Plus 1 where?
to the y.
to the y, yes. And if I put a plus 1 on the y, I'd be really close, but I'd be not exactly right. So, use it. What should I put here?
-1.
Yes. Because it's the opposite of what you would think because it's on the inside. Seems like it should have been a plus 1 to go up, but it's on the inside now, so it has to go. Can't trust those things on the inside. Except they've always been on the outside before. Now it's on the inside, and therefore we can't trust it anymore. So, since we can't trust it anymore, seems like it should have been plus 1 to go up, but it's -1 because it's the opposite of what you'd think. Okay, so now given all of that, some of you guys are fast enough learners to have caught on to this. What if I said I had x minus 2 squared plus y minus 3 squared is equal to 16? That's a little trick at the end there I pulled. See if you can handle it. I want to know, think about where this circle got moved. I want you to sketch me what that circle would look like. You're visual people. See if you can change this equation into a circle drawn in kind of the right spot. So if you're doing this right, you're probably thinking, okay, so it started there with a little circle with radius 1. I got to move it. Did you move it right 2 and up 3, even though you wanted to kind of move it down 3? All right, good. Then, is its radius still 1? Is its radius 16? No. Its radius must be 4 because 4 squared would be 16. Do you get how I cheated on you there? I said 16 instead of saying 4 squared. You have to be able to do that in your head and say, oh, so you mean 4 squared. So the radius must be 4. So there we have it. If that little radius is 4 right there, that would be my circle. It got moved to the right, 2. It got moved up 3. I know that feels weird because it seems like it should be down 3. And then it's got a radius of 4 because it always has to be put where this is squared and this is squared and this is squared because a squared plus b squared equals c squared. That's what it comes from in the first place. All right. Yes, sir.
We factor out the square.
Ooh, good question. If you wanted to get rid of the squared, you could actually take the square root of everything, and I'm going to show you that next. Back to the easiest one of them all. That one hasn't been shifted to the right because there's not anything in there, right? And it hasn't been shifted up and down because there's nothing in there. And it's still got a radius of 1. I could put 1 squared, but it's the same thing as 1, right? Okay, so that's the original circle. Now let's imagine for a moment that we wanted to have this in normal form you could put into a calculator. You can't put this in your calculator. Why not? How are you supposed to type that into your calculator? How would you normally put stuff in your calculator?
With numbers, not variables.
You can have variables. Nothing wrong with variables. Yes? It's going to be y equals. Remember how there's a y equals screen? y1, y2. It's always y equals. This isn't y equals. So I want you to solve it right now and see if you can be the kid who remembers the little twist to get y alone. Don't say it, please. I want to see who remembers it and who doesn't. You got to get y solved completely by itself. Y equals blah, blah, blah. Don't say it. And some of you are going to catch it, and then you're going to show the kid next to you, and they're going to be like, oh, I forgot that. Okay, so check with the person across from you. If you need to make little triangles, do it. I'll pause for a second while I give this a shot. Okay, I'm afraid not many people caught it. We'll see. So first step, get y alone. So you minus x squared from both sides. I hope you get, that's how you start. Now, whether I put x or 1 first, it doesn't matter too much. Okay, I'm going to put 1 squared minus x squared. And then, this is the catch that a lot of people aren't going to make. You go square root, And then this is absolute value of y. And then there's two equations, and that's why we need two equations, see, to make a circle. One equation makes the top of the circle, the other equation makes the bottom of the circle. Square root of 1 squared is 1 minus x squared. And you don't have to like figure that out. And don't think that you can find this. A lot of people think, well, I know the square root of that. No, you don't. You cannot simplify that.
What? Wait, why can't we do the square root? Why can't it be?
Good question. If you had the square root of 9 squared, that wouldn't be too bad. It would be 9, right? It would just be 9, okay? So I get why people think they can do that. But as soon as you add something in there, do you remember that whole, like, you can't cancel over addition thing? It's kind of like that. When you take a square root of that, you can't. You can't take the square root of anything that's added or subtracted. It won't come out the way you think it would. I'll give you an example. Let's say you had this. This is all underneath the square root. That would be the same as x squared minus 1. And a lot of people think, well, isn't the answer just x plus 1? Or x minus 1? Yeah, because when you break it up, you're going to have x plus 1 and x minus 1. Which one are you going to pick? You can't say the square root of this is just x plus 1. You can't say the square root of that is just x minus 1. It doesn't work. You can't do it. So don't think you can actually take this square root. You have to leave it the way it is. You don't know what that square root is. You can't just say, oh, the square root is x plus 2. Nope. And I know some of you may not have caught that, but to get a square root, these numbers have to be exactly perfect. They have to be the same. Like the square root of 3 times 3 is 9, and therefore the square root of 9 is 3. These have to be the same, right? So you cannot take the square root of that. We leave it alone. We can't go any further. So our answer is right here, right there, except this absolute value thing, I know a lot of you forgot, is going to lead me to have two answers. Y equals positive the square root of 1 minus x squared. And what's the other one? Y equals negative the square root of 1 minus x squared. And I think this will all make sense when you see the graph of this comes out to be a half a circle like this. Do you get that if this one is the top half of the circle, then to get the bottom half of the circle, you'd need to graph this one, which is exactly the same, except what's that mean? Flipped. You get how this red one would be like the bottom of the circle, and it's an exact flip of the top one? All right, I just taught you everything that you needed to know, all in about, let's see, 13 minutes. And that's way quicker than normal, and I know that's why you're still a little confused. So I'm going to go back and backtrack and recover the stuff to make sure you totally get circles here. Yes?
How come when we put the square root over the 1 squared minus x squared?
Yep. Okay, 1 squared is just 1. It's just 1 squared is equal to 1. That's the only reason that squared is gone. Okay? That could have been disappeared up in here. It didn't have to happen once I took the square root of it. Here's the key. When you took the square root of both sides, if you want this y to come out of the square root, you need absolute values. I don't want this to try to come out from the square root because you can't find the square root of 1 minus x squared. So you have to leave it in the square root. All right, I'm going to give you one more like that. Let's say you had this. X squared plus y squared equals 25. I'd like you to tell me what the equations, the two equations you could type in to your calculator that would give you that. There's two equations because when you do that square root, you're not going to forget this time to do that absolute value. Okay, so you should have thought radius. I guess easy mistake saying it's 100, but it's not 100. What is it? 10. Okay, and then because that's supposed to be 10 squared right there because everything's supposed to be squared. Okay, then the center, it seems to me like 0, 0 is a good place to start, but then it got moved where? Left 3, so where would the center be now? Negative 3, 0, very good. That's left 3 from where it would have started. All right. So how about if I go the other way? Radius equals 6. Center is at 2, 3. So what's the equation? Compare with the kid next to you. See if you get the same equation as they do. Okay, Mr. T, in the almost front row, what did you say?
I said x minus 2 squared
Yes.
plus x, or no, y minus 3 squared equals 6 squared.
I like it. And you could have said 36 and that'd been fine too. Very nice. Raise your hand if you had the same thing. Okay, good. Then you get circles. That's what you needed to know for today's homework. Now, one kid asked me about domain and range. I think that's valid. We should talk about domain and range for a second. Just to clarify, though, the very first thing is just don't fall for a trick question. Is a circle a function?
Nope.
So if they said, what's the domain and range of this function? You'd say, not a function. Okay, but if they said, what's the domain and range of this circle? You'd have to actually answer the question. So let's say that this is, it goes over 3 to the right. Then, of course, it goes over 3 to the left also, correct? And it also goes down 3 and it also goes up 3. If that's really the radius of this circle, didn't have it centered too well, but there. If that's really the radius of this circle, then you get it goes 3 in every direction. Would you please write down what you think the domain and the range are then? Domain is from left to right, and then the range is from down to up. Some of you still got that wrong in the test. It's so painful. The domain and the range, left, right, and down, up. A lot of people wrote them backwards. Okay, so left, right. What's the furthest left this thing goes? -3 to right. And what did I just do wrong slightly? Brackets. Very nice. It touches -3 and it touches 3. There's no asymptotes here. When it won't touch, that's when there's an asymptote. Remember that one graph that goes like this, gets closer and closer and never touches? That one has a domain and range that uses asymptotes because it never touches 0. But these will touch. So then the other way, it's the same thing. -3 to 3. Domain and range are the same on that one. Does that make sense? Okay, good. So what if I move the circle to the right? The radius is still 3, imagine, for a moment. Then it's not still the same domain and range. Something changed. If I move it straight to the right, did the domain change or did the range change? Domain. Now the domain's what to what? 0 to 6, because it's 3 plus another 3 makes that spot 6. 0 to 6, very good. And the range, though, didn't change, did it? All right, cool. I think you get circles. So your homework is from that, and I think you'll find that it's a reasonably sized assignment. I am going to be doing so much more in class right now, though, that I don't want to give you the whole thing. I'm assigning evens and even letters if there's A, B, C, D, E's. I think you know what even letters are by now, B, D, F, etc. All right, and that's all I got for the video for today.